In this video segment, we will be discussing about addressing modes of 8086. Addressing modes of 8086. Addressing mode indicates a way of locating data or operands. We know that inside instructions there are operands. How these operands are accessed for executing an instruction. There are different ways to do that, and those different methods are called as addressing modes of 8086. According to the flow of instruction execution, the instructions can be categorized into two. First one is sequential control flow instructions. Second one is control transfer instructions. Sequential control flow instructions. These are the instructions which, after execution, transfer the control to the next instruction appearing immediately after it. They follow a sequential kind of execution. Examples of sequential control flow instructions are arithmetic instructions, logical instructions, data transfer instruction, etc. The second category is control transfer instructions. The control transfer instructions transfer control to some predefined address or the address specified in the instruction. And this will not follow a sequential kind of execution. Some examples for control transfer instructions are int, call, ret for return, and jump. So these are the two types of instructions in 8086. Now let us see some example instructions in 8086. Move AX, 5000H, move AX, BX, move AX, 5000H in bracket, move AX, BX in bracket, move AH, DH, pop AX, etc. So when we look at these operands are represented in different formats. So in different ways we can give operands to the instructions, and these different ways are called as addressing modes of 8086. Now these are the register set of our 8086 microprocessor. The general data registers AX, BX, CX and DX, pointer and index group SPBP, SIDI and IP register, segment registers ES, CS, DS and SS, and the flag register which is used to indicate the result of ALU operation. In 8086 microprocessor, there are 8 addressing modes. They are immediate, direct, register, register indirect, indexed, register relative, based indexed, and relative based indexed. First one is immediate addressing mode. Immediate data is a part of instruction and appears in the form of successive byte or bytes. Let us see this example. Move AX, 5000H. In this example, the value itself is given as the operand. The value 5000H will be copied to the register AX. That is what is happening in the immediate addressing mode. So here, this is the AX register and the value 5000H is given directly. So this value will be copied to the register AX. Next one is the direct addressing mode. Here is an example for direct addressing mode. Move AX, 5000H. Here we can see 5000H is written inside a square bracket. This means it is a memory location. AX should be assigned with a value from the memory location 5000H in the data segment. So 5000H it represents an offset in the data segment. We have to do the physical memory address calculation in order to get the correct address. This is the formula for finding out the address. 10H into data segment register value plus 5000H. This is equivalent to shifting the DS register left by 4 bits and adding offset value 5000 to it. Let us see an example. Move AL, 5000H. This means we have to bring the value at offset 5000H in the data segment to the register AL. Assume that the data segment value is 1000H. So how can we find out the actual physical memory address? So what should we do? Write the data segment register value in bits. So this is the DS register value. 1000H is written in binary format. Shift this address to left by 4 bits. So this is the value after shifting DS register to left by 4 bits. This particular operation is same as multiplying with 10H. 1000H into 10H is same as this. So shifting by 4 bits can be represented as multiplying by 10H. Now offset is written in binary format. The offset given in the question is 5000H. It is written in the binary format. Now just add the shifted value and the offset value. We will get the actual address. Now the address obtained is 15000H. Now we have to bring the value at 1500H to the AL register. So as we can see in this figure, so this is a memory and this is the address 15000H. The value at this location is 52. So this 52 is brought to the AL register. So this is an example for direct memory addressing. Next one is register addressing mode. In register addressing mode, the data is stored inside a register and the value at the register is copied to the destination register. So here move AX, BX. The value inside BX will be copied to AX. This is register addressing mode. Now let us consider an example, move AX, BX. So here the value of BX will be copied to AX. In this example, the value of BX is 2000H. After the instruction execution, AX also will become 2000H. Next one is register indirect addressing mode. In this addressing mode, the address of the memory location is calculated by an indirect way using the offset registers. So here we can see an example, move AL, BX in square bracket. So here the value of BX will be a memory address. The value at that memory address is to be copied to the register AL. That is how this addressing mode works. The offset address of data is in either BX or SI or DI, and the segment register is either DS or ES in this addressing mode. The effective address is calculated using this formula 10H into DS plus BX, where BX register contains the offset value of the operand inside the data segment. Let us consider an example, move AL, BX. How the physical memory address calculation is done. Assume that the value of DS is equal to 1000H and offset value BX equal to 5000H. Now we are going to calculate the physical memory address. First we have to shift the value in the DS register to left by 4 bits. So this is the value in the DS register. We can see DS equal to 1000H. When we write this number in binary, we will get 0001, 0000, 0000 and 0000. Now we have to shift these bits to left by 4 bits. So this is how we shifted the DS register value to left by 4 bits. That is, we simply add 4 zeros here. So when we represent it in the hexadecimal format, it is same as multiplying with 10H. Now the offset value is the BX value, that is 5000H. Write the offset value in binary format. So 5 is 0101, then 0, 0, 0, 0, then 0 and 0. Now add these two values. We will get 0001, 0101, 0000, 0000 and 0000. That is equivalent to 15000H in the hexadecimal format. So this is how the physical address is calculated. Now in this location we will have the second operand. Okay. So from this location fetch the value. Here in this location 29H is the value. Fetch 29H, copy it to the register AL. So this is how the addressing mode works. In 8086 microprocessor, there are two index registers. They are SI and DI. When the offset of the operand is stored in any one of these index registers, we call that as indexed addressing mode. Data segment and extra segment are the default segments for index registers SI and DI respectively. Let us consider an example, move AX, SI. So SI is the source index register. It contains the offset value in the data segment where the operand value is stored. We can calculate the effective address of the data using this formula 10H into DS plus SI. Next we have to discuss about the register relative addressing mode. In this register relative addressing mode, there is an 8-bit or 16-bit displacement also to be added to find out the effective address. This is the example, move AX, 50H BX. How we'll find out the effective address? The effective address is calculated using this formula 10H into DS plus 50H plus BX. This is how the effective address of the data is calculated in the register relative addressing mode. Let us consider an example, move AL, 50H BX. Assume that the DS register is equal to 1000H, offset value BX is equal to 5000H and the displacement given is 50H. Now we are going to calculate the actual physical memory address. So for that, the first step is to shift the segment register value by 4 bits to the left. So this is the DS register value, 1000H written in the binary format. Now shift this value to left by 4 bits and we will get this. Now the offset value is 5000H, which is inside the BX register, and we have the displacement 50H. Add these three values together and we will get 15050H as the actual physical memory address. What is the value at this location? That value should be brought to the AL register. So this is how the addressing mode works. Next one is the based indexed addressing mode. In this addressing mode, the effective address of the data is calculated by adding the content of a base register, that is either BX or BP, to the content of an index register, that is SI or DI. So this is an example, move AX, BX, SI. This is the way in which we will calculate the effective address 10H into DS plus BX plus SI. This means shifting the DS register value to left by 4 bits. And here we have to add the contents of the BX and SI registers. Next addressing mode is the relative based indexed addressing mode. So let us look at an example first. Move AX, 50H BX SI. So here we can see an 8-bit or 16-bit displacement. Any one of the base register. It can be BX or BP. And an index register SI or DI. We have to add the values of displacement, the base register and the index register to find out the actual physical address. So this is the way in which we will calculate the effective address 10H into DS plus BX plus SI plus 50H. So 10H into DS means shifting the DS register value to left by 4 bits, then adding the values in BX register, SI register and the displacement value 50H together, and this is how we will calculate the effective address. Next we will discuss about the control transfer instructions. There are addressing modes for control transfer instructions. They are intersegment direct, intersegment indirect, intrasegment direct and intrasegment indirect. Now let us see the difference between intersegment and intrasegment modes. In a control instruction, if the location to which the control is transferred lies in a different segment other than the current one, then that addressing mode is an intersegment mode. If the destination location lies in the same segment, then the mode is said to be intrasegment mode. So that is the difference between intersegment and intrasegment modes. Intrasegment direct mode. Let us start with an example, jump short label. So this is an example in which the jump instruction appears. Jump short label. If this instruction is executed, the control will be transferred to label by skipping all these instructions. If the control transfers to a position within the same segment itself, then we call it as an intrasegment mode. And if the distance is within this range, we call it as a short jump. So this one is a short jump if label is within this range from the jump instruction. So this one is an example for intrasegment direct mode. Depending upon the distance between the jump instruction and the label instruction, we will classify it as a short jump or long jump. If the displacement is of 8 bits, that is a short jump, and if the displacement is of 16 bits, it is a long jump. So that is the intrasegment direct mode. Next is the intrasegment indirect mode. In the jump instruction, if we are giving address like this, if the address to which the control is to be transferred is found in a register or in a memory location, we call it as intrasegment indirect mode. Intersegment direct mode. In this addressing mode, address to which the control is to be transferred is in a different segment. That is, if we have a jump instruction, when the control is transferred, it goes to another segment which is different from the segment in which the jump instruction is present. So such an addressing mode is called as intersegment direct mode. Next one is intersegment indirect mode. In intersegment indirect mode, the position to which the control is to be transferred is given in a memory location indirectly, and that is why it is called as intersegment indirect mode. Now let us consider an example for the calculation of effective addresses for different addressing modes. So here we have the values of various registers. We have to calculate the effective addresses for these addressing modes. Let us see how this is done. First one is direct addressing mode. Move AX, 5000H. So by default, the data segment is considered. The value of data segment is given as 1000H. Inside the data segment, the offset is 5000H. So to calculate the effective address, we will just shift the data segment register value to left by 4 bits and add the offset value, and we will get the effective address. The next one is register indirect mode. Move AX, BX. So how we will calculate the effective address? So the offset value is given in the BX register. So when we look at the value of BX, it is 2000H. So this is how we will calculate the effective address. DS register into 10H. That is shifting it to left by 4 bits and then adding the offset value 2000H, and we will get the effective address as 12000H. Next we have the register relative addressing mode. Move AX, 5000 BX. Here we have to shift the DS register value to left by 4 bits and we'll get 10,000. Then we'll add 5000 and the content of BX, that is 2000, to it, and we'll get 17,000H. So the effective address of the operand is 17,000H. Next one is based indexed address register. Example is move AX, BX SI. So what we have to do is we have to calculate 10H into DS, or shift the DS register to left by 4 bits and add the content of BX and content of SI, and we get 15,000H as the effective address. The value at 15,000H should be copied to the register AX. Next one is relative based indexed addressing mode, and the example is move AX, 5000 BX SI. So here what we have to do is shift the DS register value to left by 4 bits. It is also written as 10H into DS. Then we have to add the values in BX register, SI register and the offset together, and we'll get the effective address as 1A000H. The value at this memory location should be copied to our AX register. So these are the effective addresses for the 5 addressing modes in the example. In this video segment, we have discussed about the addressing modes of 8086 microprocessor. Thank you.